I'm Joseph White. I'm a fellow at Dell in the OPI TSC chair, and I have with me Venkat Puella, who's also on the OPI TSC Technical Steering Committee, and he's from Keysight, and we're going to talk about open programmable infrastructure and why you should care about it. All right? So there's a nice logo splash screen. All right, so the objective here is to have community-driven, standards-based, open ecosystem for the next generative architectures and frameworks based on DPU and IPU technologies. I read this out for a reason. If we have a half dozen or 10 flavors of DPU ultimately, which is what we want to have a rich ecosystem, then we need standards around how you interact with them, how you control them, and how you interface to them. So a number of companies got together and formed a project called Diamond Bluff. Diamond Bluff grew up into OPI with a relatively large number of member companies now. This has actually expanded. We have 4 more that aren't on here. When I committed this deck, 4 more have joined since then, and this was 2 weeks ago I finished this deck, or a week and a half ago. So it's been in part of the Linux Foundation for about a month now. Okay, and Diamond Bluff only started last November as an informal thing, and it became more formal in about February or March. So very rapidly, everyone realized we have to do this. We have support from the major DPU vendors, with more coming. A number of the major sort of solution and endpoint deliverers, as well as customers. All right. So the background of the DPU, and I know half the people in this room or more, the background of the DPU is that you want to move work from the CPU to the an offload device to take advantage of optimizations in hardware processing, scale, cost effectiveness, isolation boundaries, and hardware accelerators, right? So this diagram is just showing that you can move a lot of things from sort of above the line in the CPU to below the line in the DPU. Okay? So if I want to control that, again, I read this earlier, I'm going to repeat it. Open ecosystem, community-driven, standards, vendor agnostic. Use APIs and standards where they already exist. This is super important. If we have a standard that already exists to cover a function or feature, we should use it. If we don't have one, we should define it, and then everyone should use it. And then we need to provide implementation examples and reference platform. This is sort of the redfish model of development, and those examples and reference platforms have been extremely valuable. Okay. So does this match to what SNIA is saying? So this is a storage developer conference sponsored by SNIA. Does this match what SNIA is saying? So the SNIA definition of a DPU is written here, and it matches very well with what OPI is saying. The OPI definition is here. Let's see. There we go. Oh, okay, I changed the slide in another version of this deck. I apologize. All right, so the OPI definition is here, and I'll go back and explain what a DPU is later, but I wanted to show that this set of criteria matches to what SNIA is saying, and it matches the general industry notion of a DPU, okay? So what is that general industry notion? And this has been shown in SNIA XPU presentations a few times. So it's basically a microserver optimized for data flow and packet processing, providing accelerators, offload engines, and local services, okay? Pretty clean definition, matches to SNIA. What that really means is you've got a card that can either be attached inside a host system via PCI, or in principle, it could be just in a switch. We've got ARM cores, or it could be MIPS cores, or it could be other kind of cores. 4 to 32 is kind of the current sweet spot. Could be 256, there are examples of that. It's got an interface into the host. It's got accelerators and offloads, encryption, security, and then networking. And the networking is particularly interesting because that lets the DPU be an L3 termination point for networking. So it gets you out of a lot of the L2 processing things. And a lot of the DPUs coming out have embedded switches, so they can forward packets port to port and do tunnel encapsulation and so on. Runs a Linux operating system, so it's easy to use. So I can load containers on there. I can load applications on there easily. It's an environment that's easy to work with. Has management interfaces and interfaces to the baseboard controller and into the host in a very natural way. So I can present SRIOV functions. I can look like an NVMe disk. I can look like a NIC. I can look like a SDXI device in principle. I could look like a GPU. I could look like a number of things to the host so that interaction to the host is transparent. Okay? Everything is essentially software defined. So if I load up different applications in different management, I can define the function to fit the use case. And I don't have to swap hardware or things like that. Also, this thing can act independently and be a control plane element. Okay, so what are the use cases the industry has defined for this? So what are ultimately, what would the APIs want to cover? Well, network switching and network connectivity. So we talked about that, the L3 termination. Gateway function, so I can use it as a packet in, packet out, and provide, say, firewall or DPI, or tunnel matching or NAT functions. I can be a storage connectivity element and offload, NVMe over TCP, NVMe over Rocky. I can do storage services. I can expose hosted system resources, so stuff on that PCI bus could be exposed out. I can do advanced telemetry collection and processing. I could be a hypervisor offload, so we see the example of that with Project Monterey that VMware has just released into the wild. Now that's for a VMware environment, but it illustrates the point. And I could host container network functions for network function virtualization. And then again, I could provide accelerators and co-processing to the hosting system. And then obviously I can help control boot and provisioning and again, provide that isolation element, right? And you can see how all of that is summed up again in the minimum expectations to say, hey, if you're gonna be an OPI compliant DPU, what do you have to do? Or an OPI compliant device. Because again, terminology gets in the way here. SmartNIC, DPU, IPU, XPU, NAPU, FAC, function accelerator card, all of those really mean the same thing and have these general properties. Okay, so what is the scope OPI has defined for itself currently? Well, for the platform, discovery, zero-touch provisioning with zero trust, inventory, lifecycle updates. For the API, we have to define the storage APIs, because again, I'm doing NVMe over TCP, NVMe over Rocky. I could do some file system stuff there, a lot of storage related things. Security, network, AI/ML. Because again, having a DPU be an adjunct processor to AI/ML is valuable. Does it relate to computational storage in principle? Yes. So I could have a computational storage personality and obey those APIs. Device monitoring, again, the DPU itself becomes a microserver that needs to be controlled and monitored. And so we want to, there'll be more than this, but this is the minimum set you need, all sitting on top of a developer platform for a set of common use cases where we define the most common elements. Okay? So to do that, we structured ourselves in the following way. Board of directors with an outreach committee to help engage in events like this, and then a technical steering committee overseeing a collection of provisioning lifecycle API and behavioral model, developer platform, and use case groups. And the deliverables are interesting. So clearly there are a set of open source projects that would immediately come to mind, and we're looking at which ones those are. Again, we're brand new, so I don't have a list of open source projects I want to reiterate, other than to say that IPDK is a subgroup of OPI, and it will be a particular set of tools and open source projects that go together to deliver on the OPI framework. One example, we want more examples. So that's a little bit of a call to action. For specifications and standards, we're saying we're going to produce new APIs using gRPC protobuf definitions with some written standards to say how it all goes together. And then where you have to adapt an existing standard, then we're going to write how that goes together. And then clearly, POC prototype reference platform test suite. We're not looking right now to be a comprehensive open source DPU software stack to run on anyone's DPU. That we may evolve into that, but that's not what we're looking for today. And so this jumped further than I thought. So with that, I'm going to turn it over to Venkat, who's going to walk you through what we're doing for each of these subgroups and so on. Just click it on. You'll be good to go. And if you have any questions, just ask, and we'll have time at the end for discussion and questions.
Okay. Thank you, Joe. My name is Venkat Pulela. I see some faces I know from the Cisco and Broadcom days. Right now I am at Keysight. Of course, we're talking about OPI. Couple of things about OPI before I get into these slides, right? What is really interesting is that the whole thing is programmable, and it is hardware, and it's full infrastructure. It's just not networking. It covers a whole lot of things. So that's what excites all of us, right? So like Joe mentioned, right, there is a IPU, DPU inside a server. Could be, in other places as we expand. So, and you have multiple entities within a server. You have your CPU complex, with its own BMC, and you have this DPU, and it's a full-fledged system. It has its own BMC, and you can bring it up. So it also brings up some very interesting problems on how do you bring these things up, right? So that to kind of address all that, we have a provisioning and a lifecycle working groups. We have 4 working groups. And each working group, there are a few more things that happen that I'll cover. So the provisioning and lifecycle is covering, how do we discover what are the capabilities that your IPU, DPU may have. There could be, dedupe, there could be encryption, there could be, some other security offloads and, things like that. So it's important to identify those functionalities and bring them together. And even before you bring them together, once you have some of that, how do you kind of build trust boundaries? There are 2 systems. There is your base CPU, and then there is this DPU with functionality, right? How do they trust each other so that the whole workflow is there's no weakest link in that whole workflow chain, right? From when you're talking from the server all the way to the end user. This group is covering discovery, provisioning. I'm just reading out there, right? I mean, how do we bring, how do you make sure there is a boot sequencing, there are no race conditions between these 2 entities, and there could be more that could be out on the network, right? And then, as usual, right, from the beginning, if you don't look at monitoring and the telemetry as part of it, if these things start only at the later layers, debugging and any issues that you may have when these systems are coming up become very difficult. So this is baked in from the beginning, that as the system comes up, we're going to track it all the way through the layers, right? This is just showing a couple of things that we are doing in terms of device discovery and provisioning. We at this point have agreed that we will use secure ZTP as our standard, I guess, right? Because why invent when something is already there? And then what you are showing here is that, because DHCP itself is inherently not as secure as we all want it to be. There is a bootstrap server that comes in, and that and then how do you make sure that you have the right certificates from each of the entities, and you can securely identify them and bring them up. And then the other standard that we are looking at and then adopting is OTEL. This is open telemetry. There are many proprietary implementations. Some are being standardized. OTEL is a good way of bringing them together. The advantage of it is that once you build whatever you build within OTEL as your interfaces, it can kind of cover a few other standards or implementations as a backend. And then even within OTEL, there are multiple, OTEL has multiple specifications. It also covers the SDK. It also collects the collector. How do you collect some of the telemetry? It has defined all three aspects of it. What we have adopted so far is only the OTEL specification. As we move forward, maybe we will take a few more of those also and adopt them as part of OPI. Like Joe mentioned, we are not trying to reinvent anything. Anything that exists, we will reuse. But we may look at multiple options that are out there. There are groups doing good work. We will consider them and eventually get there, right? And then there are a couple of things about a little bit of detail. OTEL has this whole architecture about, just like any telemetry, the data starts becoming difficult to handle, starts growing big. So there's a local aggregator, micro aggregator, as well as a macro aggregator. So at this point, we believe that each XPU will have its own aggregator module, and then across XPUs, you may have a macro aggregator. Right? And then idea is also to make sure that we have a minimum set of common metrics that we will adopt, right? Because the minimum set with a standard way of interfacing to it makes it usable. Otherwise, and then each of the implementations could definitely add a few more things, but we believe it's important to have a set that works across multiple of these XPUs we are supporting. So the other working group, this is very important, is an API and a behavioral model working group. This is standardizing how do we interface to all the functionality that the DPUs and IPUs offer. It's also standardizing APIs too. It's standardizing two sets, right? One is like a host facing, another is really, how do you manage these things? So there are both sides of those APIs are being standardized. We're defining the taxonomy. We are creating models, and then we're just getting started. There are more work needs to be done in terms of how do we adopt any specification languages for these models? Can we compile them and automate a lot of these workflows? So there's some good work that is happening in different places, so we will adopt some of them also. And we will reuse all the industry APIs. At a high level right now, these are the four broad areas. There is a networking being a big set of use cases that XPUs will help offload, accelerate. Storage is another big area. Security. And AML, we haven't yet started on it yet, but we believe that's going to be a very big use case for, especially when you look at the companies that are joining and trying to standardize across, right? You have NVIDIA and a lot of other SmartNIC vendors have done first generation AML on the FPGAs. All those things will come into picture, and we want to go there. And we're also building a reference client. While you have the models as a reference model that will evolve, we will, whatever APIs we create, we will have a reference code so that you could take that and get at least the API part of it moved much faster, right? This is kind of showing in a little bit of detail. This is work in progress, so you may or may not find everything you're looking here. Let's say if you look at networking, right? We are not just considering SONiC. There are many implementations. And because we're talking about programmability, we're looking at P4, we're looking at SONiC ecosystem. There is a project called Dash, which is mostly focused right now on the gateway and networking side of using DPUs for accelerating. there is good progress that is being done there, and we want to bring some of that and evaluate. So networking has a lot of standardization happening in different places, but we want to pick up one that will be useful at an infrastructure level, right? I mean, it's easy to just look at networking and storage in silos, but I think what we will do is to really see if there is anything that is better when you step back and look at as infrastructure as networking, storage, virtualization, security, then the view would change, and this is a good opportunity for us to bring in a lot of those to kind of build that from ground up. The other working group we have is a developer platform. This is just a way of driving the adoption a little faster. But we are not, at this point, chartered. We may go there where you will have a lot of open source, but we're not getting started. This is going to be a simple platform, maybe a simple model, so that you can get started, at least the interfaces, how do you connect to them, a simple orchestrator and things like that. The backend implementation may still be your vendor-specific SDK, but it's a little hidden. And there could be more common open source work that comes later, but we are not getting started with that. And to just kind of facilitate all this, we're trying to create a multi-vendor lab where we can bring in hardware from multiple vendors, put it in one place, make sure they work together, or they compliance and things like that. We may not get into the performance testing kind of thing in the beginning, just to kind of limit the scope. At least in few dimensions, because if you really think about open programmable infrastructure, the scope is so big, right? So it's important for us to take small steps and then get there eventually. But you will have a simulation environment so that there is enough functionality and functional testing that can be done from the beginning, CI/CD, so that it's automation friendly. The last but not the least, it's all of no use unless we really have some real use cases. You can see by looking at the members who are all joining, right? ZTE, Verizon, and others, they're all giving the specific use that they see. And then we are talking to them systematically and gathering those use cases. And they will feed us in terms of what we will prioritize as a group. There are one or two of the initial use cases with actually there are more discussions happening. The broad categories are, like I said, storage, security, networking, and AI/ML. But you will see a lot more use cases that kind of go across these boundaries. It's a system level solutions. On the storage side, you can relate to the NVMe over PCIe, which is what you have internally, and maybe you are really connecting to NVMe over TCP bridge. So you're kind of, this DPU comes in between and acts as a bridge between these two. That's something being looked at actively right now. On the security side, a basic firewall, a simple rule-based, whitelisting kind of applications. Again, driven by, specific customer requirements and vendors like F5, one of the members, and others, Dell, Red Hat, what each one of them are seeing. Some of those use cases are coming in here and being implemented. So the takeaways and call to action, we are a young group. There's a lot of momentum that is being built. Like Joe said, last couple of weeks, multiple folks have joined. It is very relevant to this group. Feel free to come join us and then give us the use cases. And this is a good time for you to leave your mark or make sure that you are doing something that somebody uses eventually in terms of relevance and customers, right? And you see a broad set of vendors. It's not just the hardware, the DPU vendors are just the storage vendors. You see really customers coming in and giving use cases. And so, I am at Keysight right now. I am looking at, how do we test all this, right? What are the common test frameworks? So there's a broad set of folks looking at different aspects of it. Very good time to join and drive it in a way that's useful to you and your customers. So I think that is it. Okay, so you can definitely go back and look at this slide. It gives you on how do you join. We have very active Slack groups. We have mailing lists. All the like Joe mentioned, we have board of directors, technical steering committee, all the management side. We have done enough to get started. And then
there's a GitHub with documentation and code on it. So there's a real GitHub with real documentation and code. So if you go to the OPI project GitHub, you can see real progress there. So that's how we're tracking everything. In fact, the GitHub is more active than the mailing list, which means there is real work being done.
right, yeah, come join us.
All right, questions, thoughts? Yes, sir.
Yeah, you didn't mention NVMe. Does that play in here at all?
So NVMe is the transport protocol. NVMe modules would run on the DPU. The NVMe would obey its own NVMe standards. The configuration of like the CDC client or the configuration of the interfaces into the server. So how do you define an map NVMe drive and so on? We'll cover or touch on some of that. But again, the transport is the transport. It has its own protocols. We want to use those. NVMe over TCP, NVMe over Rocky.
I was thinking more, can it look like an NVMe drive?
Yes.
And so you have submission queues and completion queues?
Yes.
Okay.
Yeah. No, it looks like an NVMe drive. So the average DPU in the industry today can look like an NVMe drive with the full NVMe API exposed on PCI. So NVMe PCI is a thing, it already exists. And having a common way to configure that and set it up, very valuable, because multiple vendors have implemented it. All of the major ones, in fact, all of the vendors have implemented that, including the ones that don't have a full DPU out on the market yet. They're all implementing it too. Everyone is. Is that?
And
that would be true of, say, again, this is true of all the services you load. If they have a well-defined way to behave, the DPU will emulate that. If they need additional config support, that's what we want to define in OPI. Make sense? Yeah. Okay.
Yeah, just to repeat the question.
Other thoughts and questions. So I guess there's one other thing we didn't talk about.
I just want to repeat the question,
Okay.
right? Just because it's getting recorded or somebody else might be seeing from outside. So the question was that you didn't mention NVMe. So we did mention NVMe 10 times now.
Right. And so there's one other point I want to make, which we didn't cover in the slides, but I want to say it. We are looking at how to collaborate with all of the other SDOs. So we need to figure out how to collaborate with Redfish, with Dash, with FMDS, with SNIA itself, both on SDXI and computational storage. And we don't have any agreements in place, but both at the board and the TSC level for OPI, we know we're going to have to define all those relationships to other SDOs to make this successful. And again, it's because of the flexibility of the DPU that I outlined that we have to do that. And we know if we try to boil the ocean from scratch, that's basically an automatic lose. So if we try to redefine standards that are already generally accepted, OPI will collapse under its own weight. So although we didn't have a slide saying that because we don't have those relationships established, we know that that's the initial list of groups, and there are other groups that we have to deal with. ORAN is another group we have to deal with because ORAN, OCP is another group we have to deal with, right? And then there's a hardware aspect which we're not going to touch at all. This is all for the software. So the hardware form factor, that's all covered by PCIe CXL, that's covered by card form factors and other industry standards. So this is about the software and components that run on the DPU. Does that make sense to everyone? Because I want to make sure that I mentioned that since we didn't actually have a slide that said it. Other questions? All right, let me ask for some feedback. Is this sensible? Can we actually, so A, do we have to do this? And B, given that I think we do, does anybody think this is a bad idea. It should be, in vendors where in is anywhere between 3 and a dozen ultimately, should just define their own thing. And, when you want to use them, you're writing a whole bunch of code to control them all independently. Or do we need a common effort?
Reframe it differently.
Yep.
I think that I see an API for computational storage. I see redfish, swordfish type stuff, and things like that. So it sounds like this is different. So maybe is there already a different organization? Same goals, same stuff, but a different.
So the purpose of this, as I said before, is to define the common elements that let you install all those other personalities to the DPU. And then when you have the other personality, you control it through the standard defined to support that personality. But you have to have a way to bring the thing up, provision it. You don't want to talk to n different API endpoints, you want to talk to one. So you need a API broker to map, an API dispatcher to do the mapping. You don't want to have n ways to do telemetry off of the DPU itself, right? This is you really want to define a common way to do that. Networking, there probably ends up being 3. We probably won't have just SONiC. We'll probably have SONiC plus OVS plus maybe one other. But if I put this thing in a computational storage role, then I would obey the STIA computational storage API for loading the computational storage software. But to bring the thing up and put it in that role, I'd want to use OPI because now I can swap out DPUs in that computational storage role, for example. So that's the split we've been working with. That's the mindset that we've been working with. There are other ways you might have structured it, but and said, well, each of those standards will define how to run on each of the flavors of DPU independently. And now once I have it in that role, I just use that standard. It seems better to have the common infrastructure layer. I mean, look how successful Linux has been by saying Linux is usually mostly Linux. I mean, there are variants and things have diverged, but the original Linux value prop was it's just Linux. SONiC for open networking has done so well because it defined common, core functions and core use cases. Do we get to a SONiC-like model? Maybe not. Redfish is successful because everyone said, yeah, we need some stuff in common that's beyond IPMI, and it's been successful for server management because it said, let's go define the common stuff and then vendors can extend off of that. Make sense? That's the.
So this is.
Yes, sir.
UEFI for DPUs. Sort of.
No, so UEFI is a boot standard. This is more than just that. This is kind of full provisioning. You need to define some container management in here. You need to define some higher level APIs. And then there's some open source projects for infrastructure pieces that ought to be done in common. So you could think of it as UEFI grown up into being a kind of a full server card standard is one way to think about it. But really, this would use UEFI to boot possibly. So that's one standard you could use to boot.
This could be like this is the next layer, and that's giving you the functionalities in a standard way across multiple hardware vendors. You have a question.
Yeah, well, based on Gary Gardner's keynote this morning, it looks like he's already got some use cases that would fit this model beautifully. And so my question is, are you also working with research communities that seem to be farther ahead in this area because they see the benefit of this, so they've been working on this for a while. Is there any collaboration with the research community for OPI?
So there's no formal collaboration, but informally, yes. And also a number of the big large-scale customers have brought forward ideas on how they want to see the API structure. So Verizon, for example, just brought forward into the provisioning and lifecycle group how they would like to see networking, storage, and security chained together in a framework so they could swap out those components easily. So they came in with a proposal, high-level proposal for how they're thinking about it, and do we want to go that way? And so that's under discussion.
Yeah, I think one of the key things that Eric brought out, what's the best place to put my code today might not be the best place tomorrow.
That's right.
So I need to be flexible what I discovered, where I want to put my accelerator.
That's right. And that's why, and so again, that's why embracing existing standards, thinking of it as I'm loading containers or programs for FPGAs or programmable pipelines in a standard way. So my function is very different depending on my use case, but my infrastructure to load that function is the same. And the way I interact with it is the same up to the point where it really is doing something different. And I know that's a bit of a vague hand-wavy thing at the end, but there's not a better way to explain that separation. Other questions? Yes, sir.
You say the growth is mostly vendor-driven, user-driven, or an mix?
It's a nice mix right now, and the mix is improving.
Is some of the, for instance, API defined as using them, and so hopefully this could be done with a little bit more like user input rather than saying this is what we had in hardware, so we expose it to you and how you deal with it.
That's right. So we have, there are, I'd say about a half dozen reasonably active customers. And then there are the DPU vendors themselves that are involved. And then there's the, hey, we've got the, the stuff DPUs go into, both in terms of physical platforms and solutions involved as well. And then we have the, we're going to consume and test DPUs guys as well. So we have sort of a nice mix across the whole spectrum. The one thing that would be nice to have more input from, honestly, is the tier 1 clouds. So we have service providers, we have tier 2 clouds and so on, and we have a little bit of tier 1 cloud because you saw a Tencent in there, but it would be nice to have more tier 1 cloud participation. So they're participating a little bit in Dash and so on, and I think that'll come with time. So again, because remember, they do solutions by themselves for themselves to a large extent, but again, broadening the adoption even there would be valuable if we can pull it off. But even without that, for everyone else, having a common way to do it is good. And again, we have a good mix of the different kinds of input, as you say.
Yeah, I think just by having multiple vendors itself is helping to normalize how to access. It is difficult, but that's the whole goal, and I think we are making progress there.
Anyone else? We're doing well on time. We've got a few more, another 5 minutes or so, or if there are any other thoughts or questions. Are we completely crazy? Is anybody saying, man, you'll never pull this off, or don't go here? Or you might say, hey, you can go here, but you may not pull this off. I mean, all those questions are valid, and we've debated them internally. We decided to do the Linux Foundation formation off of Diamond Bluff because we realized that there probably is enough momentum to pull that off. And again, we're trying to set ourselves modest intermediate goals. This isn't a 5-year project to deliver, some giant thing. We can take it in bite-sized pieces and do a piece at a time. So.
You want to mention the DPU bot?
Yes. So there's Mark Carlson back here is hosting a DPU Birds of a Feather later this evening, and we have a whole track tomorrow on DPUs. So details of individual vendor implementations, performance stuff, solution space. So there's an entire track on DPUs tomorrow and Thursday, I guess. It's a little bit tomorrow and on Thursday. So, and it's 7 o'clock tonight for the DPU buff. Anything else? All right, thank you very much.
Thank you.
We'll end the session here.